Hey guys, so for Earth and Space today here, we're going to kind of jump ahead in our notes a little bit. I'm going to have you guys take a look at some of these, some of the forces here that are involved in weathering. So where we ended off last time was talking about using the kind of the quick background on rocks here. So I'm going to go ahead and expand that. All right, and so this goes into our next slide here. So weathering, erosion, deposition, oftentimes refer to this as WED, is a kind of a three-part process here. Weathering means to break down rock, erosion means to remove it, and deposition means to settle it. Sometimes weathering and erosion can kind of overlap because they almost happen at the same time, but they are kind of separate processes technically. So weathering is the process of breaking down rocks into smaller pieces or sediments. And we'll talk about what sediments are here on the next page. But weathering actually has nothing to do with weather. And that's what a lot of students sometimes mistake that for. So weathering has nothing to do with weather. Although weather can play a slight role in weathering, but it doesn't normally. Erosion is the process of moving that sediment that gets broken down by weathering. Erosion can be done by either water, wind, ice, or gravity. But like I said, a lot of these, those four that we talk about there are also involved in weathering too. So there is some overlap. And then the deposition is where sediments get laid down. So if you go and make a deposit at a bank, you put money into it, right? Or you put money down. That is where that word kind of comes from here. So deposition is when the sediments that got eroded and moved end up settling down. So generally WED is described as kind of destructive forces because the first two parts of that, weathering and erosion, are destructive forces because you're destroying rock. But deposition is actually considered a constructive force because it's actually building up some of that new rock. And as sediment is kind of being deposited maybe at the bottom of like an ocean or a lake or even like a river bottom, those sediment layers start to layer on top of each other until they compact and cement together to form a rock. Usually if we're talking about an ocean, that rock that will form is a limestone rock. Limestone rocks form in marine type of environments. So all the shells and bones and sediment, it could be the sand particles too that are in the ocean, compact and cement together to form that rock. But erosion and deposition will be discussed in our next unit. So we're just going to be focusing on weathering here. So again, just remember in your head, weathering is the breakdown of rocks. So this is all destructive forces that we'll be talking about here for the next week or so. So what is a sediment? We talk about it a lot, but how do you classify a sediment? A sediment is a smaller rock particle that comes from larger rocks. So any larger rock can form sediments of any size, really. This chart down here gives us a classification for different sediment sizes. So let's start here so it's anything from microscopic to anything larger than a foot. So let's stop here at the top. Sediment here is the biggest classification that we have is boulder. And a boulder is more than 256 millimeters. That is about 1 foot. So if you want to write, 1 foot or 12 inches kind of behind there is just a reminder that's about 1 foot. So if you have a rock that is bigger than a foot, is classified as a boulder. It doesn't matter if it's 1 foot big or if it's the size of a house. It's all a boulder. The next one here is cobble. So cobble is anywhere from 64 millimeters. So 64 millimeters is about 6.4 centimeters. That's to about to that foot mark. So that's about 4 inches, I'd say, or so. So anywhere from 4 inches to 12 inches would be cobble. A pebble is anywhere from 4 millimeters to 64. So that would be, 4 millimeters is 4 tiny little lines on your ruler there. So pretty small, but still definitely visible up until that kind of 4-inch mark there. Gravel, so anything that's classified as gravel has a diameter of anywhere from 2 to 4. So again, visible, but getting smaller here. So 2 to 4 is gravel. And then you'll notice here we have like 5 different kinds of sand. Very coarse sand, medium sand, fine sand, very fine sand. The word coarse always means like bigger in this case, and fine usually means smaller. And so that's all of this that's happening here is various sizes of sand particles just, getting smaller and smaller and smaller. And then our 2 smallest ones are silt and clay. So these are less than these are microscopic. Or fine sand here too. That's 0.0004 millimeters. That's you couldn't even measure that at all. So, and same thing with clay. So these 2 down here, silt and clay, are microscopic, but when they come together, they basically make your water like really murky. And whatnot here. Actually, this is 5 sizes of sand here instead of 4. So if you want to change that to 5, you can. There's 2 types of weathering based on what happens to the minerals in the rock. We have mechanical or physical weathering. You'll hear me use both of those terms, so just kind of get used to that. Both terms mean the same thing here. So mechanical or physical weathering is where rock is broken down into smaller pieces by physical forces, but it doesn't change the chemical composition of the rock. So my rock is broken down by physical forces. We'll discuss what some of those physical forces are, but the key thing here is that the composition of the rock does not change. So you end up with the same rock, same properties of the rock, same chemical makeup of the rock. You haven't changed anything like that. So rock is simply smaller in size, but the minerals that are in that rock remain the same. With chemical weathering, this is another breakdown of rock by chemicals, which changes then the composition of the rock. So if you're in my chemistry class, we're just getting into talking about physical versus chemical properties. This really ties almost directly into that as well. Physical weathering is just changing the amount of it or size of it, but you're not changing the composition. Chemical changes do. So it's very similar understanding here. So in this case, the rock is getting smaller in size. That's the whole point of weathering, is to break rock down into smaller pieces. In this case, the minerals have changed. So forms of mechanical weathering include, and we'll talk about each of these individually here. So ice wedging, abrasion, which is wind, water, gravity, and ice. Notice that I had all these 4 under erosion as well. So I told you there is some overlap here. Organic mechanical weathering or physical weathering. Organic means living, means it contains carbon, and most things that contain carbon are considered living beings. And so we'll talk about 2 kinds, plant root wedging and animal burrowing. So the first type here that we'll talk about is ice or frost wedging. We all know that water freezes, and when water freezes at 32 degrees Fahrenheit, it expands a little bit. You probably knew that too. And when you are in a time of year, especially when you have constant freezing, thawing, you can start to end up with water getting into a small little crack like here. So water seeps into the crack, kind of fractures the rock as it freezes, and expands that crack. So you can see right there. So this is ice that's in here. As it expands, it cracks the rock a little bit. Now, eventually the temperature gets up to the point where this ice in here will melt and it'll become water, and it'll do the same thing. So it'll keep kind of going back and forth through this cycle of freezing and expanding and thawing. And what can happen is you end up with a rock that can almost split in half like this. So in this case, I started out with a big boulder, and now I have two smaller pieces. And again, I can kind of keep doing the same thing to those as well. This process also is what forms potholes on our roads. In Minnesota, we know the potholes are bad, especially during the spring. And this during the spring is when we see this constant cycle of freezing and thawing, right? Because during the day, it might get up to like 40 degrees maybe, right? Because it's starting to get a little warmer. And then at night, it gets down to 28 degrees. Well, at night, then the water freezes in our cracks inside our streets, and then expands, and then the next day it melts. More water can get into there now because the crack has expanded a little bit, and then it just keeps happening. So more water comes in, more water freezes, making and expanding that crack bigger. So you can thank this process here for our abundance of potholes in Minnesota as well. But here's some other examples. So this would be, a real life example of a rock here that has been cut open by frost wedging. And here's obviously just your average everyday pothole. Abrasion is our next one. So abrasion is the grinding and wearing down of rock particles against one another. You guys may have heard of the term called abrasives before, maybe when studying. If you work, in your parents' garage, or if you ever used anything in shop, some cleaners are known as abrasives. It just basically means they get anything away. They kind of scrape away anything. So that's what the word abrasion means. And so we have the 4 different kinds that we mentioned already: water, wind, ice, and gravity. So this is where particles, again, we actually have a physical touching and wearing down of rocks against one another. So that's what abrasion is. We have a physical scraping and grinding of rocks against one another. So water, abrasion, moving water can carry sediments and smaller rocks that can wear down the sharp edges of rocks that are maybe sitting on the bottom of a stream or a river that are too heavy to actually move with the stream. But they aren't too, heavy to be sitting at the bottom, kind of getting hit and pelted by smaller things that come by. And so this is the process here that forms river rocks. Some of you may have these around your house as landscaping. If you go up to the North Shore, you will see a lot of rocks like this. It doesn't always have to be at the bottom of a river. It can be, any sort of beach that has moving water by it. So like I said, North Shores, Superior, Duluth area, you'll see a lot of these. So again, these rocks didn't start off round like this. They had jagged edges and corners and sharp jagged edges and corners, like you've seen with the rock samples that we had. But over time, they get worn down, smaller sediment bumps into it, and eventually they get to this nice rounded shape. Then we have wind abrasion. Wind doesn't maybe seem like that strong of a force, but it can be. But it is probably the weakest of all the 4 forces that we have. So wind abrasion happens when wind carries small sediment which can basically sandpaper other rock down, other larger pieces of rock. So the wind, which is carrying, it has to be a fast-moving wind. You have to have a place like a desert area type landscape where you do have a lot of access to sediment, and it picks it up and it starts like moving it with the wind. And like I said, the wind almost becomes like sandpaper, and so it wears down the rocks at specific points. This is Arches National Park in Utah. Some pretty cool rock structures. Obviously, this rock didn't form this way. It used to be all together one solid piece of rock, but the only part here that is left is this, some of the stronger part, but even that's getting worn away. Same thing with this rock over here. So the sediment gets picked up and it has been hitting the softer part of the rock, which is down here, over a long period of time. Eventually, this will obviously just collapse, and you can see other parts of it have collapsed already as well. But again, this rock didn't, form like that. This is like the last Lone Ranger standing here in a sea of sand. And our third one here is ice abrasion. Ice abrasion deals with glaciers. Glaciers are actually moving masses of ice. A lot of people don't know that they actually move. They move slow, but they move to the force of gravity. But these are probably the strongest forces of physical weathering that we have. Glaciers can carry anything from sand-sized sediment to boulders the size of houses. So they are a really strong force behind them. And what happens is that the glacier, the ice is solid as well. The ice can carry other solid sediments, and then the ice itself can actually scrape and the rock kind of below a glacier as well. So it picks up everything from, like I said, small sediments to massive boulders. And then as glaciers are moving, whether they're growing or retreating means to melt, the rocks below them can show striations. The word striations means lines. And they're basically almost like fingernail, like scratches within the rock. So these are lines that show evidence of scraping and abrasion. Look at this picture here first. Abrasion and another term called plucking kind of go along with this. Plucking is when the glacier picks up the rocks as it travels. So here's my whole glacier up here. The part here with the blue arrows is solid ice. We can see kind of at the bottom here of the glacier, right here, kind of a zoomed in picture here, it is picking up part of the bedrock, which is the solid rock the glacier is formed on the bottom. So it picks apart and breaks up boulders and things like that. And then as it does that and continues to move, it drags those boulders along the bottom and scrapes and wears down rock and picks up more. So here's an example of those striation lines that you see. These form very slowly, but they do form, in pretty big abundance. You can see as it melted, it left behind these rocks here too.
Or cartoon version.
Sorry, my TV just came on. And then our last form of abrasion here is gravity. So usually you don't think about gravity, too much as a force when it comes to rocks, but it does have a pretty big impact on rocks, kind of an invisible force. So rocks that are in very steep cliffs eventually end up falling, especially if they lose the support from underneath them as rocks are continuously, maybe they're being weathered by something else. Sometimes you'll see this happen on the shores of lakes or even the North Shore up in Duluth, Lake Superior area. The water let's say this, I know this is kind of more of a desert landscape, but the water would kind of hit down here at this rock here and erode this rock. So you have that form of weathering. And then what happens is it makes the rock on tops unstable because they lose that base. And then that rock, falls down. So you just kind of end up with this cycle here. But as rocks fall, it's not only then that's impacted. As they fall, they can crash and break into other rocks and particles and make them into smaller pieces. So if you look at this picture here, this is more of a desert landscape, but obviously all this rock that's down here came from the cliffs up here. And so you can see some bigger pieces here. And then you also see lots of smaller pieces. And, part of that comes from, as rocks fall down here and move and come down the cliff, they're hitting into each other with a pretty good deal of force. And so they can break apart as they continue to fall. And then the last two that we'll talk about here is organic weathering. So these are caused by living objects. And so we have root wedging, sometimes known as root pry. So if somebody, the word pry means to split apart, like if you pry something open. So that's what this can do. So these are the roots of trees, plants, usually pretty big trees, which are strong enough to actually pry through rock in search of water and nutrients. And I have a couple pictures of them on the next page too. So these are really interesting. You'll see these in cliff type of environments. Sometimes they can be fairly large trees too. So the roots are powerful enough to actually pry through, weak parts of rock to get to the, fastest way to get to water and nutrients. Animal burrowing then is our last one here. So animals can burrow into soil, they can disrupt it, they can allow it to be moved. Animals can't really usually do anything to solid rock. It's hard for them to, actually, it's not like they can chisel out a hole in solid rock, but they can definitely mess around in soil. And soil technically is maybe not rock, but it's definitely sediment. So here's a couple examples here. So here's a tree that you can tell is just kind of growing through cracks and has split apart rocks. If you look up root pry and root wedging, you can see this happen too. Another place that you can see this just around here in Sleepy Eye is if you've ever, been biking or walking or running along a sidewalk and all of a sudden there's this huge, lift up in the sidewalk or kind of a V shape or a lip. That is caused by the roots of trees nearby that have that force to lift up and separate concrete from each other. And then here you have some, looks like prairie dogs that make and move large amounts of soil and sand around as they make their homes and tunnels. So that'll be what we'll be covering in our notes today.